Okay, so today let's continue with our compiler. And yeah, in um, in the previous episodes we were able to finish off the Lexer, basically get all the tokens. So how that looks like is, let me just run the Lexer on some file that I have, and it gives us all the tokens and stuff. So if we just look at error tokens, we get illegal tokens, but otherwise we get like the ones that we are used to, right? And I mean the language, how it looks like. Let's look at a file where I implemented like a list, and yeah, it's like really similar to Java in a way, and it's also a bit functional looking, and yeah, I mean it's not something that I would code in every day, but it's a nice example to have a compiler for. It it has a really simple syntax structure, so it's easy to write a compiler, or at least our front end so far of the compiler. So yeah, we have the Elixir. Then we also finished off the um, AST. So yeah, if we look at the AST, it's basically just the usual AST structure. That's what we printed, like the program, the class, the name of the class, all the attributes, all the functions, and so on. And yeah, if we provide like I forgot, it was parser, and we give it some error stuff, it will tell us the file and the error. So basically we take the invalid token from the Elixir stage, and in the parser stage we actually display the errors to the user. So yeah, and yeah, that's what we did so far. We managed to finish off the AST. So now we have the AST in simply put. So we have this structure, this kind of grammar. I think, yeah, that's a grammar. So what we have to do next is to type check it, because school is statically typed. And yeah, um, we just have to follow the rules from the book, and figure out how to do type checking. But like, as a kind of a small spoiler, we are gonna have to work the AST, right? And basically build some kind of context. We don't really know yet what the context is. We'll have to figure it out. But you can imagine that we'll add the classes to that context, all the methods, all the variables, and what we have to do is check that the variable that we found right now, or the function call or whatever, has the type that it says it has in the context. So that's the idea. So yeah, I actually copied some tests in this semantic folder, and yeah, we'll just have to go through them and see what happens. So the first one will be pretty simple. It's just for classes, and if we scroll up to the classes section, yeah, I mean the kind of errors and I guess rules are scattered around the book, which sucks in my opinion, but it is what it is. And we have like some information. Sometimes you have to read the entire thing to catch it, but since we have some tests, it's gonna be easier. But like in classes, it says classes may not be redefined, so that's something we have to keep in mind. So if we see a class twice, like D for example, that's not good. And also int is redefined, but I think that might be another kind of error. Who knows? Here, let's not go into inherits yet. So yeah, we have some classes which are redefined, so that's, as I said, not really good. Then for features, we don't care about features right now. Oh, inheritance. Great. So here we have some rules about inheritance. But oh, these are discussed in section 8. Yeah, this thing is pretty complicated. So let's go to section 8, see what it is. Each object. So probably it's gonna say it is an error to define IO. You can inherit IO, stuff like that, right? So int, it is an error to inherit or redefine int, basically. So like this is an error, right? And I think also self type you cannot know the uses. So okay, yeah, I mean, not sure why Hyperlink kept crashing with OBS. It says like a segmentation fault, but whatever. If it crashes again, I'm just, switching to i3. I don't care anymore. So, yeah, or Sway, I don't know. But, yeah, like, let's hope it stops crashing. I'm not sure why it did. But, yeah, I was like, explaining the types or something, or self-type, I don't remember exactly. But, yeah, let's try at least to get um, some of the tests running. So it should look similar to printing the AST basically, but instead of printing the AST, we're gonna do some checks, right? So I mean, even the first test is pretty complicated. So let's see. Okay. So yeah, let's do something like semantic.c. And I think we also need a semantic.h. So I said it's gonna be similar to print.ast. Let's take print.ast. And here I have semantic.h. Like this. Okay, and this should be type check, for example. And we get the program, and as I said, it's gonna return the context, but right now we don't really know what the context is. So let's go in here and include semantic.h. Well, that's I didn't write it like that. Semantic h. And if we look in print.st, yeah, we might also need stdio for printing the errors. So yeah, print.st. So I mean, it's gonna be similar. So first thing that we want to do is to try to understand these type environments and the context. So yeah, basically we're gonna have three things constituting the context, I guess. We are gonna have an O object, or we are gonna have an array, basically in O, that's gonna contain the variable v that we have in our scope and its type. And then we're gonna have m, which is like methods, and it's gonna be each class is gonna have some methods, right? So we are gonna have C is the class, F is the method name, and this is the type of the method. So these are the arguments, and this is the return type. Tn is the return type. So yeah, I mean it's gonna have some more complicated stuff, and there's also something like, for example, the let construct or whatever introduces like a new variable, right? C here, for example, we type int. So when we encounter a let, for example, or a case, or what else defines variables? I think just let and case. We need to add to our context the variable, and when we exit from the let, we have to remove it from the context, right? So yeah, here it has some stuff. So here is more like a pattern matching structure. So if in our context we have the C variable, then we return T, and if this is not our variable, then we just go to the next one and try it. So yeah, I mean here it has some definitions that look pretty weird, but yeah, like I kind of understand them. So basically, given this context of objects and methods and the current class, if for example for identifiers, right? If this identifier we find it in our objects and it has type T, then the identifier has type T. Obviously, it's pretty straightforward, and then becomes more complex. For a sign, for example, if we have this ID, it has type T, right? And then we need to check that the type of the expression we use for a sign is smaller than, is more strict, let's say. So is an implementation. For example, T is the interface and T prime is the class, right? Like that's the idea. So yeah, pretty weird definitions. I mean, for function calls, it's insane. But I mean, hopefully we'll be able to do at least one or two of them, just so you um, can understand it, and then I'll try to do more on my own just to finish the semantic analysis. So yeah, let's see. So how are we gonna start? Well, we actually test semantic 01. I guess we actually need the class int is redefined and stuff. I guess we kind of need the thing. I mean, yeah, the context right now, right? To figure out which classes we have in our context. So let's see. Um, so let's have maybe a structure here. Struct program context, right? And in this context, I think we need to have the list of classes. And let's use I mean, I think we need also to have like class context. Struct class context. And for the class context, let's have char pointer name. Or how about if we take a look in our parser? I think we used, well, it's parser.h. I think we had line and column, so it's like node info. But we don't really need the line and the column, because we are gonna print the error instantly in, let's say. So let's look at our semantic. So yeah, and the context is gonna be returned, so that's something. So we're gonna keep the name for now. Name, and how about the parent? But for now, let's just put the name. So we have type check, and yeah, first of all, um, we kind of need to go through all the nodes in the program. But for the first, let's do it like in multiple passes. So in the first pass, we are gonna define all the all the classes. Then in the second pass, we are gonna enhance, let's say, these classes with a reference to their base class. And yeah, so like the first thing though, we might have to add all the default stuff in the context, like int or IO object and so on. So let's go ahead and try to do that first. So where are the basic classes? I think IO, for example. So we have so let's say, well, I mean void object context is gonna take in, I think I want to give it a program context, right? Not sure, context, or I mean, this is gonna be like a static function, program context. We give it the context of the program, and I mean, we could just type them to make things easier. Type def, and was it like program context? Type def class context. So yeah, okay, I mean, have no idea why like it gives this error in OBS, but I've just tried to use i3 because yeah, I mean, what the hell, I don't know. Pretty weird. Have no idea. Anyway, let's just continue. So include ds.h. I mean, let's be honest. It's better to just have the code than fancy-looking window managers. So if i3 works, then I don't see a problem. But I need to remember the keybinds and do a small config, like at least have the keybinds and stuff for i3 because I don't know why it's in white theme. Anyway, so yeah, let's have the class name, right? This is basically the name of the class. I mean, we don't even need a name of the class because we are gonna have, well, it would be nice to have a hash map though in a program context for the classes, but I don't really have a hash map ready. So that's why having the name in the class context is fine for now. So here I'm going to need a ds dynamic array of classes. Okay, so we need a dynamic array of classes, and yeah, then I guess inside of the object context, we just need to create a new class context. So we are going to have struct class context, and we can have class um, equals object like this. Although I would say name equals object just to make it nicer. And this thing should get a program context as the so void type check just to find it, and it's here. So yeah, we actually then have to move all of these in here. So we need to expose the stuff. So yeah, basically we'll get a program context and we have to initialize it with stuff. So for example, with the class with this thing, then what I'm thinking is this is gonna have a struct class context pointer to parent. So basically, it's gonna be like none if we don't have a parent, or I mean, it's gonna be object anyway by default. So it should be object at least, right? And object is gonna have null there, so that's that. And yeah, let's try to. So here we add the object. Then let's say, I mean, how about maybe instead of doing each one individually, let's say st standard lib or std lib context, right? And here we do std lib context. Basically, this is the standard lib of the of cool. Okay, then we need string, and parent is gonna be, well, we can't really do that because yeah, we cannot do it like that. We have to first add it into the dynamic array, and only then we can take the reference to the dynamic array itself. So this dynamic array append, we need to give it context classes, and here a reference to object. And basically, let's say it comes uninitialized, so we do this dynamic array init, and we have to initialize this with size of classes. So inside of it we are gonna have that, so it should work like this. Or I mean, how about doing it in here? So we actually, like when we initialize like context init, for example, context init, it initializes everything, right? So initialize the classes. Let me check if it still records. I think so. Looks good to me. Anyway, I mean, it's better to just be able to switch like a maniac between them. So we append, right? So yeah, I would say that So like we have a few options though. Here we could keep a char pointer to the parent name, or we can keep a class context to the parent name. Which one do you think it's better? I mean, I would say class context because it's like a linked list, you know, it's like a tree but in the other direction. If you think about it, I mean, I would open up GIMP and draw it, but I don't know how to execute Rofi in this thing. So yeah, uh, but if you think about it, it's gonna be like a tree structure, but the links are, instead of going down, they're going up towards the root. So that's how this class context looks like if you keep start class context there. And if we use a char pointer, then we would have to always go into the dynamic array, search for that name if it exists. If it's not there, then it won't work. So yeah, that's the main idea. So it really depends on your preference, I guess. Keeping class context is nicer. So let's keep class context. Why not? Pointer to class context. So here, actually getting the struct class context pointer object context, we need to, this doesn't work like this. This would give me just the value though, so it won't really work. What I actually have to do is go into the items themselves and get the first one pretty much. So it's gonna be context classes items, and that's it. And it's really scuffed. It's really scuffed. But it's like it's the first item. So because if I do get, what actually happens is if we go and take a look at how get works, it actually does a mem copy. So it's not a direct reference, it's just a copy. So it wouldn't work. Maybe to just make it a bit more pretty, I guess we can do something like this. And then say it's the 0th element, or I mean the first one, and we take the reference to it. It's pretty much this thing, right? But let's just keep it with items. It's the same thing. Okay, so then we are gonna have another class context. We are gonna have int, and the parent is gonna be the object context. Int class, right? I mean, let's say object class, and this is the object context. Then we're gonna have, yeah, sure, fair enough, we append it, and by appending it means we just copy it. Then we don't need the context. We need a struct class context, and the next one is string, I think. String, we append it. Then we need a boolean class with the same thing, and IO. And I think IO is also, where's IO? IO, I mean, everything comes from object, from what I think. I always have to check because I don't know if, I mean, hyperlink was just, you know, stopping and bringing me back to SDDM, but I don't know if i3 will crash if OBS shits the bed. Anyway, uh, so this initializes the context with our first few classes, right? So yeah, I mean, I guess what I can do in ds.h is to actually have another function instead of get that would be like dsh_def dynamic array get ref, and this would just give me the reference of the one that I'm searching for. So maybe that's a bit nicer, a bit more clean, let's say. So let's just implement that real quick. So yeah, I should have defined the, but I mean let's just let Chat GPT do it. So perfect. That's what it should look like. So getref now it's a bit nicer. So object something like this, but it should be ref, and this can be equal to null, and we can say here something like that. I don't think we need to specify. We actually need to specify. Okay. Um, yeah, I guess. I don't know. Yeah. Anyway, hopefully this works, right? So yeah, we can use getref for that. We need the reference to the object context, like to the object class. So the first one, because we did initialize. Okay, so everything is good. So let's have void type check class. Right, so type check class in what I said earlier is we just work the classes, so these nodes of the program, and we have to check that they are not redefined or they are not, I don't know, they are not bad, let's say. And with that, we just add them to the dynamic array. We just add them, right? So type check class, well, I don't know how to call it because it's like type check initialize classes or something. Yeah, I mean, as you know, like the hardest thing in programming is actually naming stuff, and yeah, that's good. Wait, what I didn't check. Well, I mean, I can see that the mic is working, so not really an issue there. Okay, let's not lose our focus with the current setup. So we have a list of classes. How can I say that type check initialize class? Type check, yeah, I don't know. Well, what we're gonna call here is first we need to build the class hierarchy uh, into passes, right? So let's see, build. I mean, well, I would check for duplicate class definitions right away because that's when it's gonna be possible. But yeah, I was hoping for a naming convention from ChatGPT. Let's see. So if we get something like redefined, illegal names, redefined. Yeah, see, like the first few errors are gonna be well, you redefine the class, or the name is illegal. That's a new one. Yeah, obviously it's gonna be illegal to have a class named self-type. Then we have something for int, and yeah. So let's say man, it's so difficult to get a good name. So let's say program context class. Well, yeah, it would be like a function to add a class, but not right now. We just need to have oh, I cannot believe I'm stuck on this one for like 5 minutes. It's so embarrassing. So build, you know what? Build class hierarchy. So we are gonna take the program node, right? This is the one that contains a list of classes, and we are also going to take the program context, which also contains a list of classes, but they look a bit different. So what we need to do, I mean, context init makes sense to call it here though. Well, no, it doesn't. We call it here, then we build the class hierarchy, and here what we actually have to do is to have a for loop int I equals 0 through the program classes count, right? It is a bit strange that I haven't really, I don't have a length function. That's nice. Well, we don't care about length, so I++. So what we have to do in here is to have a class node, pointer, which is a class, and we just have to, sure, we could do something like items like this, but this needs to be a pointer. Oh. So what's easier to do is the dynamic array get what it gets in a dynamic array, so that's classes is a dynamic array. Wait, what's the error? Oh, it's a pointer. What? It's not a pointer. Oh, we have to give it a pointer. So it's the address to this array, and we get back the class node basically. So now what we have to do is create a new class just like this. So let's just create a new class just like that. We're gonna say so that's the class node. This is the class context. Let's rename this to node. Let's rename this to context or class actually, because yeah. So we get the node, right? And here we use node dot name. We can with node info, and node info contains the value. So here we can pass in value like that. Yeah, I think so. I don't really remember how these guys are initialized, but I think it's like token literal and should be fine. So initialize the class, and the parent is gonna be null because we don't have a parent yet. Okay, so yeah, see, like in i3 it works. That's perfect. Then I guess, yeah, I'm just gonna use i3 for from now on, because to be honest it looks a bit cleaner, less animations and stuff. Maybe it's better for recording. So we have a class, right, and we just da append it. But now that's not always right, as you saw in the errors. So in 01, here we actually redefine int, right? Here we do something wrong with self type, and then we redefine d. It's we cannot add it straight away. We have to do a check first. So what we have to do is have another static void, or I mean could be even an int, and it could be something like check class redefined, right? So what we have to do is we give it the name of the class, we give it the context, and we have to loop through all the classes. So it's strange how it's something different. What? But why did they say it's a pointer? It doesn't have to be a pointer. Oh, that's good. But yeah, it doesn't have to be a pointer. I don't know why I made it a pointer. Right, like if we look at, for example, our, let me just go in program node. See, it's not a pointer here, so I don't know why I made it a pointer in there. Anyway, so here we are gonna do that. But first, yeah, we have to check if the class is redefined. So we loop through all the classes. Here we get the reference, although we could just, get like class like this, and here we can just do a get, just a simple get into class, and then we have to check that the name, like if the name is equal, then the class is redefined. So let's say is class redefined. Let's have like a predicate naming convention for this stuff. So yeah, this thing is gonna tell us if the class is redefined, and yeah, if it is, then we should, so 01, we should show the error. But yeah, we have to show the file name and stuff. So let's go into the parser and see. So the parser also took in like the file name. We also need to pass in the file name here. Alright, I need to pass in the file name, and now in semantic.c, let's pass in the file name here. So init context how about then the context having also the file name inside of it, just so we make things a bit easier. Like for example, char const char pointer is going to be file name. Yeah, also like names and stuff could be const char pointers, but I don't know. So context file name could be file name. But like the file name can come from outside then, so we don't really need to say that. Like we can leave it from outside and yeah, just make the function call smaller. So program context is gonna come in with a file name set. Okay, let's go into the parser.c thing, and here we have like parser show error format. So we can reuse this function to show the errors. Is class redefined? So let's put it like up here. This is gonna get the context, the program context, and stuff like the format. So yeah, const char pointer file name. Okay, something like that. So let's comment this thing out, just so it has, maybe we can regenerate it with. Okay, so if the file name is not null, then we print it. Then we have to print something, something like that. But we need the token that failed. So we could, oh, that works. Scrolling on the bar works. Yeah, I was thinking, what if we get a token, but we don't have a token, don't we? Well, let me check in parser.h how we took the token. So parser current. We have the tokens. Okay. So then, what do we do with the token? We were taking a line. Okay. I mean, we can use the node itself for the line and the column. So class node, it has a node info with the line and column, so we can use that, right? So let's say and I mean if we do checker semantic 01 the ref, it says class okay, so I need just the line and column, and then the error is gonna be in the format, but we still need the line and the column. So how about passing in unsigned line, unsigned column, and everything else, something like that. And here we're gonna say line column and find semantic error, and then we need to import the stuff for wait, it's where I thought it was stdr. Okay, perfect. So now we have context show error. So it's going to be something like this, and let's do some defines like we have inside of this thing. So we need, for example, redefine. So context show find, but it's like show error redefined. We don't really have an expected, we have just class show class redefined error parser class. This is the context. Alright, so we're gonna do something like class line. Well, this is gonna be actually the node name, so it's just gonna be this thing. Oh, I'm stupid. It's gonna be, where was it? It's gonna be class node name is gonna be this, so it's gonna have value line and column. It's gonna have value, but I think it's gonna be with point. It's gonna be like this. Class is redefined, something like that. So here we're gonna check if is class redefined error, but whoa, I pressed caps lock. Okay, so that shows that it is class redefined. Now we need another error type. Class has illegal name. Static int is class invalid. So we're gonna take program context. Well, we don't really need a program context, but it's if str compare, let's see, nah, self type, oh no, something like this, and here we return 0. Is class invalid. Else, if is class invalid, we show class has illegal name. Well, let's do this class self type. Although is class invalid, define class invalid error, and it should be class has illegal name self type. Illegal name, and we can actually do %s here. we can try to do percentages. So then here we can say class invalid error, and on the else case we just append it. Alright, we don't want to have other weird errors, so we just append it. And I think this should be everything to get the first few errors right. So let's go into main.c, and we might need another argument. So arg parse, let's see. So it's gonna be type check, or like semantic. I would use capital S, semantic check. So first we do lexer, then we print the tokens. So whatever, it should be like a separate function because it's humongous. Then the syntax, we print the st. Oh, we need to import include semantic.h, and here, yeah, basically semantic check. Yeah, well, in semantic.h, we could actually rename this to semantic check, right? Okay, so it takes in a program and the program context. So program context. Okay, so this thing actually builds the context, but see, it's like it has to do it every time, basically. Like, yeah, and it should probably tell something, I guess, if it got an error. Well, it could be the same as I did uh, for parser. So in parser, I had something like a result, which is set in show error, although that's not really ideal. It actually did a job, so maybe we can do the same thing for semantic and have a field inside of context. That is like fine or not fine, something like that. So yeah, either this thing or having everything return the result, but probably it's gonna be easier to just have an int result, for example, and in show error, although yeah, it's not ideal, let's have context result equals 1, and yeah, let's imagine that context result equals 0 at first, something like that. I think that should be fine. So here we can just do this thing, and yeah, like, see, actually not printing the errors might make sense. So yeah, unsigned semantic could also be like, I mean, this thing should be file name equals file name or something like that, and the rest is initialized inside of semantic check. But yeah, like maybe should have in semantic check, maybe we should have something like if the flag is set, only then you print the errors. Otherwise, we might print errors for everything else. So yeah, right. This prints the errors anyway. So yeah, I mean, if you cannot build AST, it doesn't make sense to run semantic check. So you kind of have to do it. Then if syntax, okay. Then I mean, yeah, context. Well, I mean, even this thing could be an int, and it could just return context result, something like this. And it makes things much easier. You don't even need to care about the result. That's on the thing. So yeah, pretty much something like this. We stop that, and if semantic search is 1, then we just exit. So it's more like, well, if you want to do lexing, it does lexing and it stops. If you want to do parsing, then it has to do lexing, obviously, and then it does parsing, and if it fails, it fails. If it doesn't fail, then it exits, and whatever this does. Then for semantic, it does semantic analysis. If it fails, it exits. But if you want to stop at semantic step, it just stops here. Perfect. So that's how we should do it. So now if we go into C and we make, oh no. So in semantic, let's see at line 60, different signs. So count is unsigned in. Well, you know what, I don't really, I guess I haven't used that before. And at line 82. Okay, whatever. So let's remake. Wait, what? Syntax check. Okay, so we want to do semantic 01, and I think we should be able to see that class int is redefined. This class has a legal name, and this one is also redefined. So if we go back to main.c, here we pass in the file name, but we actually want file name to base name. Actually want file name to base name. So let's see again. I mean, that looks good to me. So it's exactly the same as this one, right? Yeah, it's the same thing. Oh, but I made a spelling mistake in semantic.c. This should be redefined, NED, redefined. Okay, so actually that's good, right? So we build a class hierarchy, but it's more like, yeah, build a class hierarchy and build parent hierarchy would come next, I guess. So static void build parent hierarchy, and we have to pass in all of this stuff. Let's see what happens here. So we need to go through all the nodes again, just like that, to go through all the class nodes. Okay, and what do we need to do now? I guess we just need to take the parent node if it exists, right? And we need a pointer to its context. So if node dot node what class node superclass and the superclass is like node info. So to check that if it doesn't exist, we have to check the name of node info. That sucks. So value is equal to null. Not necessarily that we continue, but let's say char pointer parent is gonna be something like this, right? And if parent is equal to null, then parent is gonna be object. Object is like the base class for everything, so that's what we want. Okay, so that's the first step, and then the second step is to do some dynamic array and we need to get, I mean, we can reuse node, I guess, because it's also a class node, but it shouldn't work. What the hell? So like in classes we have context, so it should be class context pointer class, and here it should be class. Okay, so that's how we actually have to do it. We need a reference. It's like in is class redefined or something. Okay, we need a reference to it. Oh, it's actually like here. Yeah, we need a reference, and I guess we know that's it. That it is at, well, we don't know what index it is though. So yeah, this is scuffed. So we have the current node, and we want to search for the parent. So this should be like maybe parent. Oh, it's redefined. Okay, so then the actual superclass, like the parent class. We need to find a pointer to it. Okay, and I think we also need a context for our class that we just found. So I think that's also required. Class context class equals to null, because it already exists, right? The class that we search already exists. So let's have another char pointer name is gonna be the name. So we have to search for this class, right? And also for this class, and then do the assign. So we need 2 for loops. So for J, context class is count, so we have program and context, right? We have to do class context. Yeah, that sounds good. And then the same thing, but for parent instead of name. So we need the two classes. Okay. And then what we have to do is say that the I mean, if parent class is equal to null, then we're gonna have an error. Is equal to null, then we're gonna have an error, and else is gonna be class parent is equal to parent class. Okay. So how does the error look like? It is class has undefined parent. Okay, so let's take this and let's go to our list of defined. So define should be undefined parent. Find parent error. I mean it's class undefined parent error, context class and parent. So it's class has undefined parent. Okay, perfect. That looks good. And now we can fill in this thing with the right stuff. We haven't called this yet. Build parent hierarchy. Okay. Build parent hierarchy. So class A is undefined parent BB, which is on the other way around. So that's not good. And also the line and column are not right. Also, we passed in something stupid. Probably should be something like this. It is name and then the superclass, class and parent. But what I'm not sure about is 1.7. I want to see the seal. Yeah, it should be, I think it should be 121. So it is the parent which we highlight. So it's parent and parent. But we get the segmentation fault, which is a bit strange. So where do we get the segmentation fault? So the class, we search for the class. I mean, oh, when we don't have the class. Okay, so if class is equal to null, then we just continue, and then else if and else, because the class can be null from before. We just have to ignore that. So has undefined parent type, self type, but that's more like illegal. So let's also have another check if that checks for illegal parent name. So static int is parent invalid program whatever, and we cannot have int, string. To be honest, I don't remember which were the culprits. So let's see. The int is an error to redefine or inherit from int. The same for string, the same for boolean, but I think IO is fine. It is an error to redefine IO, but it's fine to inherit from IO. So let's change this to self type. So we have int bool self type. Okay, so is parent invalid? And we can check that in here. So if is parent invalid, then we can just show the error and then continue. Right, we can just do that thing. I guess we can also, I mean, let's try to be a bit more efficient. Let's say if class is null, then we just go ahead and whatever. Then let's also go continue here, and let's just make the code a bit more pretty. So like the first error that can appear is if the name is invalid. Well, I think that it should be like this, because if the class doesn't exist, then I think we shouldn't even care about the parent or whatever. It's like, okay, like the class is in, the class was something wrong with the class, so we don't care about anything else about this class. Something like that, maybe, I guess. Then if the class exists and it's fine, then we can just, look at the parent with the superclass, and if the parent is invalid, we show that, right? We show that. Okay. Then we take the parent class, and if the parent class is not existing, then it's an error. Otherwise, we just set the parent of the current class to that. So yeah, maybe I would change this to parent name just to make it more consistent with the other naming, right? Like this is the current name and the current class, and this is the parent name and the parent class. So it looks, I don't know, it looks pretty clean now. So let's rerun this thing, and it's gonna say, oh, this should be something else. So we have an error that looks like illegal parent, undefined parent. So we have defined class illegal parent error. Class has illegal parent. Yeah. Man, Copilot is really good this time. That's surprising. So this should be class illegal parent. So we have undefined illegal parent, bing bing boom boom. And the last one is inheritance cycle. Oh, that sucks. But that's a cool problem to solve by itself, like finding a cycle inside of a graph. So yeah, but I still kind of want to get at least one test going. So let's see. So obviously that can be done only after we finish building the parent hierarchy. We cannot do it while we build the parent hierarchy, and we cannot do it here. So first we build the class hierarchy, then the parent hierarchy, and now we have to check for the thing, check for the cycles, that's the name of the error, right? Inheritance cycle. Yeah, so it's a static void, and the name should be like check inheritance cycle, and we need to give it the program context and inheritance cycle for class. So we're gonna have to iterate through all the classes, right? Then we need to get the current class. Okay, let's not get spoiled by this stuff. So let's go up here and say define class inheritance cycle. Class has no, it's more like inheritance cycle for class, I guess. I mean, obviously the errors don't really matter. We can put any errors we want, but let's just keep it simple. Inheritance cycle for class. Okay, so how can we actually solve that problem? Well, we need to get the parent, and as you know, the first parent is like the highest parent. I don't know how to say, the most generic or general parent is gonna be object, and the parent of object is null, so we can go up the chain of classes until we find object or null. Doesn't matter, any of them work. So the idea is to do a while loop while parent is not equal to null, for example, right? And inside of this thing we need to say if parent is equal to class, and this works because we used pointers, right? We used pointers, so we can just check if the pointer is the same. If the pointers are equal, then it means that we came around a loop and found that the current parent is equal to class. So it's yeah, I mean the current parent is equal to class, it means that it was a cycle. That makes sense. So we have to show the inheritance cycle error. So it's gonna be class line column and the value. So what's wrong with the class? Class is gonna be, I mean, yeah, like here we no longer use, okay, so here we try to get the line, the column, and the value. Let's see, so we have name. Do we really need to keep also the line and the column? I mean, to be able to show this error, kind of, yes. So how about keeping then a node info here? Node info, and we have info. This will break like almost everything, but damn. Oh, well, yeah, I was hoping we can do maybe something like this. Name object, or is it like value, right? Yeah, it's like value. So we're gonna have info, and here we are gonna have value. So we don't have line and columns for this stuff. Okay, let's do then info, something like that. Like it's nice to refactor using Copilot because it gets things faster. So here we have dot info dot value. Though this info could be actually called name. Yeah, and we have like class name value just to keep the line in column. So looks like, let's see. So build class hierarchy. I don't get why we don't see errors. Should be like this when we build a class hierarchy. And I think that's the only fix we need to do. Node name. When we build this thing, we need to string compare with value, like that. Here again, we need to string compare with value. I mean, yes, like, would be nice to have a function for this stuff, but we don't really care about it. Let's see. So in here, we actually need to pass the name. Right, and then we, whatever, close that stuff. So yeah, I think now everything is good. So we check for inheritance cycle, and if we build, oopsie doopsie, it loops because I forgot to say that parent is equal to parent. So yeah, we get E, F, and G, and it's the same thing. Let's do the checker for semantic analysis. Oh, yeah, I forgot. We need to also update the checker. Let's include here semantic. Yeah, we're gonna do intermediate representation and stuff, but not right now. So I guess that's the first thing. This range anyway. Cool C is gonna be yeah, whatever. And inside of checker we need to have semantic. If it's semantic, then semantic analyzer. Let's say semantic analyzer is gonna be just whatever sem. So let's see if this thing runs now. Yeah, and it passes the first test, which is pretty nice. Okay, so if we go back to our semantic thing, yeah, so far we build the class hierarchy, then we get the parents and check for inheritance cycles. So that's the first thing. I want to go third one. So I'm curious to see what's for attributes. Maybe it shouldn't be that hard to get attributes going. So let's make a small commit. Say feature added Sam check for classes or something, I don't know. We just build the context for classes. And yeah, let's try to run this thing. So let's make it and let's try to build it to run it on the main tests. So it should be fine because all the classes in main are good. So that's a good sign, I guess. So let's look at program context. So to make this thing work, we actually need to add attributes in here as a list inside of class context. So if we take a look at this type environments, we have to basically define big O. Right? We have to define big O. So yes, we're gonna have probably a node info for the name of the attribute and the class context. How about the class context for the type of the attribute? So maybe we're gonna have a type def structure, and let's think what are we how are we gonna call the attribute. So because it's not really attribute context, it doesn't have any context, it's more like attribute info or something, you know. Type def. Yeah, it's more like attribute info, and here we're gonna have a dynamic array of attributes. And yeah, we're gonna have to initialize it with attribute info and add all that. So let's try to do that because it should be pretty chill to do it. So when we create this bad boy, we have to ds dynamic array init, not really the methods but the attributes, and this should be like maybe attribute info. I was thinking it's like info node versus context node, right? One node provides like a context of stuff inside of it, and the other kind of node is just info. I have no idea, because like in an ideal world we should have a map here instead of an array, so it would be a map from node info to node info, but yeah, attribute pair, that could work. It's attribute info, the data of the array. So we have that. To be honest, what I would do is also add the self attribute. I don't know what error it shows. So ref illegal name self. So yeah, it's not really redefined, but yeah. Oh, and this is like with inherits and stuff. So B redefines inherited attribute. That's gonna be interesting. So yeah, let's not really put self inside of the attributes. I'm not sure. Right, like not sure if we should add it because I don't know how to say it's self type. It's a strange type, self type. So we just initialize the attribute, and that's all we have to do here. Now let's say another function, static void, and this one should be maybe build class attributes, and we have a structure program node, program context. So build class attributes is gonna take in a program, although it should maybe take in just a class. But it's gonna be like a for over all the classes, and for each class we are gonna do something inside of the context. So yeah, it's more like we are gonna have a class context and the class node for each one. So it's gonna be interesting to see how we can synchronize. Well, I mean, yeah, I know how. We are just gonna search in the context like we did. Where did we search? Here we did, right? And we're gonna have something like this. Something like this. So basically we go through all the classes in our program, then we have to search in the context for that class. If it's not there, it's whatever. And the next step is to search, well, it's build class attributes. Yeah, see, that's why I meant maybe having a function for this is gonna be nice, but yeah, whatever. So this should be like do a for loop over all the classes inside of the context, and if we find something we return the reference to it. Yeah, maybe something like node to context or something, and it returns the class context. Yeah, like why not? Why not? So let's take this thing and have maybe like a static void class node to context, and we should get a class. No, we should get a program context. Why isn't context class node? Node could be a copy. We don't need, and the class context. So we have this for loop. We have char pointer name is gonna be the name, and basically that's everything. And we actually have to send in, I think, a double pointer to make this work. So this should be like this. And first we have to say that class is null. Okay, so we do class node to context. We could even just return it because it's a pointer. So how about doing it with return? Yeah, why not? So it should be class context pointer, and instead of doing this thing, we can just do here a return C, and here we return null. So now instead of having to overcomplicate with that, we can just say something like this: class node to context, and we can reuse this function. So we have the defines for errors, we have the context in it, checks for errors, so let's put it somewhere here, I don't really know. So instead of doing these for loops, we can just class node to context, right? It should be, that's not good, it should be with parent name. Class node to context. Why not just have the char pointer name here instead of, maybe that makes it easier. Where did the other thing disappear? It's over here, so it should be class to context. Maybe that's class to context name. I mean, let's see if it still works. Yeah, it still works. Fine. So class to context is a bit nicer to have. Okay, so where were we at building attributes? So we initialized it, I think, somewhere around here. We initialized the attributes. That's good. So we get the context of the class, and yeah, now we actually have to loop through the attributes of the node, and yeah, let's see, maybe, as I said, we can have a function build class attributes. Maybe let's say build, like build attributes, and build class attributes will be just for a single class. So build attributes. Yeah, not sure yet. Let's just do for loop for unsigned int j equals 0, j is less than node arrow attributes dot count j plus plus, and here we should do something like we take the attribute, okay, we have to create an attribute info. So first let's check the name. So let's go up here. Let's have a comment implementation, whatever implementation. These are, I mean, that's context in it. Error checking, let's move error checking from here. Let's put it here, error messages. So we have like an idea of where's everything. And implementation should be maybe here. So static int is attribute invalid, or is it illegal? It's more like illegal. So we need Yeah, we don't really care about the context. I don't know what to put here, like we don't even use this. So is attribute illegal? Like even for is parent illegal, we don't use that. Or for this one. So let's fix the errors. Okay, we fixed all the errors. And what's next to do is we have the error check, and we also need an error message. So define attribute illegal error. But we need the context when we show the stuff. Okay, attribute illegal error is going to be attribute has illegal name. Class A has attribute with illegal name. So class S has attribute with legal name, and we give it the, and it's 6 5, so 1 2 3 4 5 6. So we put the line and column of this thing. So attribute, yeah, perfect. So yeah, we go down here, and if is attribute illegal, then we show the error. Otherwise, we append it, but not so fast. Let's do continue. So I would say, okay, like the name is illegal, but we still kind of have to check for redefines. First of all, we have to check for the type. And we have to check for inherited attribute. So yeah, I mean, these are not really that bad. So let's go to this one and say static int is attribute redefined. We give it a class context, and we just have to search inside of this thing if string compare, then it's redefined, and otherwise it's not redefined. So yeah, pretty simple like that. And here let's do an error message. Attribute redefined error should be class A has attribute, no, class A redefines attribute X, redefines attribute. Okay, so now if we go back, is attribute redefined, we show that error. So let's see for 02 what errors we get so far. We don't get anything because we haven't called to build class attributes. So we get class A has attribute with legal name self. Let me just legal name self. Then the redefine of X, and that happens twice. Yeah, but we need to look now for the type of the attribute. So let's go back. I guess first is to check if it's redefined, right? And maybe then check that it's undefined type. Yeah. So let's see. The error should be something like has attribute with undefined type. So is class redefined? Is class invalid? We don't really have. We don't have that. Is class redefined? Wait, how did we check that parent is not defined? Oh, yeah, I know how we did. So it should be, we did something like this. Class to context. We took the parent class and saw that it wasn't there. So we have to pretty much do the same thing. So if no, let's do something like class context type, right? And for the class context type, we should probably, let's just copy paste this thing because it's gonna be okay. So we can make it a pointer, the type, and let's have to say class to context of this thing. And if type is null, attribute, and the error is like undefined type error. So we have to create this macro in the error checking section. Undefined type, class A has attribute with undefined type, has attribute %s. So we have to say class, maybe attribute, class attribute and type, and the error should be placed on what? On the type or on the, so let's see, probably this is line 9 and 12 looks like it's this, to be honest. So class A has attribute y with undefined type c. So I have to put here the attribute value, and that should do it. So here we need to say attribute name and attribute type. So let's rerun this. Okay, it looks the same to me, so that's good. And then what's a bit difficult is to get the redefined inherited attribute. Okay, I mean those are the same, that's nice. So build class attributes. We are gonna have to check all the parents though. So class context pointer parent is gonna be pointer to parent, and while parent is not equal to null, then we have to do parent is equal to parent, and it's not gonna be a cycle. We made sure that it's not gonna happen. So just have to find. So how we did here, class to context. Now let's just make another for loop for unsigned k, unsigned int k equals 0, k is less than the attributes count. We have to get the attribute from the parent. Oh, but this should be done in a separate function because yeah, see, like first we create attributes in all the classes, and only after we create attributes in all the classes we can check for redefined attributes, I guess. Yeah, So we cannot really do this in here. We need, let's just put it somewhere. Copy this one, maybe like this. Maybe copy everything from there, and this should be build class attributes. Maybe like check parent class attributes, something like that. Check parent. So we go to the program nodes, we take the current class. If it's null, it means that we had an error previously, so we stop. We continue with the next class. Then we have to go to all the attributes of the current class. Right. Then we need to get the attribute, obviously, whatever. I don't know why I had a brain fart. Then we take the parent class and we go over it and over all its attributes. And if we find an attribute twice, oh no, it's let's say a parent attribute. Right, let's say parent attribute, so it's gonna be here parent attribute. So if we find, don't even know, yeah, I mean we just show the error and I think we can break. I mean we should also break from the while loop because we don't want to cascade into a lot of errors. So yeah, now how can we should stop equals 0, and here let's say or should stop or something, and here we can set should stop to 1 and break. So that fixes all the issues. Okay, so let's see again. We go through all the attributes. Here we added the attribute, so we are good to go. We added the name and the type as an attribute info, and here we are gonna check the parent classes. So we go up the chain of parents, and if we find an attribute that has the same name as the current one, we need to show a definition error, and should stop becomes 1. But I mean the error looks a bit different. It's not really attribute defined, it's more like define attribute defined parent error. Class redefines inherited attribute. So class S redefines inherited attribute X. Okay. So instead of this error, we should say that. So segmentation fault, perfect. It means we did an oopsie doopsie somewhere. So we take the class, here I don't know why I was going through that. I should probably use the context of the class. So let's say class attributes count attribute info attribute, so we can get from the class like that. So this is the node. I don't even think Yeah, I mean, we need the nodes, right? Not really, we can use the context classes. Okay, no. Let's use the program classes because we don't want to do it for object and stuff. So yeah, let's just keep it simple. Let's just go through the program classes, now get the context of the class context, then we go through the attributes from that context, although we can as well just use the nodes, but I think it's better to use this because we want to check only the ones that we added. Okay, so we check only the ones that we added inside of the context, then take the parent, and while the parent is not null, yeah, maybe this was an issue, I don't know. We go through all the attributes of the parent. So yeah, see here we use the context. We get the info from the parent attributes, and we have to check that the names are equal. Otherwise, we say that this is redefined, and here we can use, I mean, we can use class. I don't know why it was using node name. Yeah, I think, not sure why it's segmentation faulting. So let's just do printfs. Why not? Printf for the win. So check attribute for B. That's nice because B should have an error. So we do another printf attribute x. Okay, that's good. Attribute x. No, actually B doesn't have an error. So this should be an end. Obviously, rookie mistake. And then it says class A redefines attribute x. Oh, wait, why is it not class B? Should stop and should run. Maybe it should be uh, should run. It should be something like this. Oh my god. Wait, what? Printf. Let's see the parent. First time is gonna be A. For B it's gonna be A. That's right. So it's gonna be A. It's gonna come inside of this thing. It's gonna come inside of this. So let's see printf the attributes. Not sure what the oopsie is. So printf we have an error. Okay, we have an error. So the problem is here. So attribute. So we get attribute line column, attribute value. Oh, we don't. We have to do the class name value. Let's do just like this, and here let's put class name. And not really sure. Class B defines inherited attribute X. Perfect. That looks good on the second test. Yeah, I mean, pretty much that's what we have to do for like all of them. Maybe just lets and cases will be a bit different, but yeah, like even method is gonna be the same in some way. So I mean, yeah, I guess I'm just gonna do them by myself until I get into something that's a bit more interesting on this one. And maybe type checking functions or type checking let statements. Maybe those are cool. I have to see. But yeah, I mean, it's not really difficult. It's more like you need to write a lot of code to get it to work. So build class attributes, we did that. We did check parent class attributes. That seems to work. So yeah, I mean, I guess like having a helper function here to get the attribute that you're searching for could work. So we don't need all this stuff. What else can we maybe improve? Like yeah, I think only this thing could be turned into a function. So far, make things a bit better because this just oh yeah, and we'll have to add methods into this one, but it's pretty much just like this, but with the methods that we're gonna add for string and for IO. So that's not difficult. So I mean, just create a new function for attributes, another one for method, and it should be very similar to this idea, right? Like we're gonna get the context and we need to get the attribute out of the context. But since it's attribute, it's just gonna be the class context, and then yeah. So we're gonna have to implement this and this functionality, and then all the type checking rules. I mean, pretty. Uh, I mean, they are straightforward, but you have to get them. So that's the main thing. So yeah, all in all, we got the first two tests, and to get all of them, it's just just writing the code. It's gonna be similar to doing attributes. So I think I can get that done on my own. So let me just do a commit for added attributes, and yeah, I think this should be everything for today. Yeah, so I guess I'll see you on the next one. See you.